Hi, welcome to Vision classes. It's a classes for IGCSE, GCSE, AS and A-level student around the globe. So today we have to discuss one of the interesting question from the further mathematics, that is paper 3, further mechanics part, May June 2021. So let's jump on to the straight away. Question number 2. We have here hollow hemispherical ball of radius A has a smooth inner surface and fixed with axis vertical. Particle P of mass moves in the horizontal circle on the inner surface of the bowl. So there is a bowl like this, fine, and this smooth circular ball is just a rotating like this, fine, and at a height of x above the lowest point of the bowl, P particle P is root of 8 GA upon 3, fine. This is again it's a further math question and they put out little bit challenging question, so we will here try to solve it. Firstly, we will draw the diagram, simple diagram. It will help us to understand all the things relating to this bowl, fine. So here firstly hemispherical bowl, fine, and this is here vertical axis. Let's say this is vertical axis here. Now it has a radius A. Radius A has a smooth inner surface fixed with axis vertical, fine, and now the particle of mass m moves in the horizontal circle on the inner surface of the bowl at a height of x. So height x above the lowest point is this one, and here we have a x distance, okay, and here this particle P is here, fine. This is particle P. If you just draw all the points relating to this point P, we will be having this also radius A, right? Then nextly this is theta we have. Then nextly this one, this distance is actually A minus x, isn't it? So this is rotating horizontally, right, at this above the axis. I hope you understood all this part relating to the point P. Now if you look at the point P is rotating, so here we have to take the even normal reaction, okay, normal reaction, it's a downward weight. Then we have the outward is n sine theta and upward n cos theta relating to this mass. Now here one more thing is that this radius, we will assume the distance from the vertical axis of this particle P is just a r. So r is distance of particle P from vertical axis, okay. Then nextly, how we can calculate this r is equal to, we can take the square root of, here this is Pythagoras theorem, you can apply here, fine. And for this r, you can take the a square minus a minus x bracket square, okay. And if you simplify this one, you will get r is equal to 2ax minus x square. This is the value we will get for r. Now we have to take here even cos theta. Now theta, this theta, so cos is adjacent here, a minus x over hypotenuse is a. So cos theta is equal to a minus x over a, and sin theta is equal to r upon a, which is equal to square root of 2ax minus x square upon a. That's it. So that's a sin theta. Now these are just a initial arrangement we have to make to solve the further derivation. Then we have to take the relation of centripetal force equation, okay, centripetal force equation, and then we have to simplify this one. Even here we have a v is given, that is v is equal to v speed, means v is equal to root of 8 GA upon 3, and we have to find out x in terms of a, we have to find out, isn't it? So here look at this one, we have to take the firstly centripetal force equation, horizontal forces. So it's a n sine theta is equal to mv square over r, right? Because it is moving along the here horizontal surface, right? And horizontal surface we have a mv square over r is the motion along the circular motion, we can say, fine. And we have v is equal to root of 8 ga upon 3. This is given in the question and we have to find out x in terms of a, right? So n sine theta is equal to m times 8 ga upon 3 r. This is first equation we will get. Then second equation, the vertical forces, sum of all the vertical forces. So n cos theta is equal to just a mg, isn't it? So this is second equation we will get, fine. Equation from equation 1 and equation 2, tan, if you take the just their ratios, sin theta upon cos theta is tan theta is equal to 8 mga upon 3r is upon mg. This mg get cancelled out and we left with 8a upon 3r. So this is, we can say, third equation. All right. So from the actually diagram, from the diagram, if you look at this one, this is tan theta. What we can take, tan theta is opposite r over a minus x, right? So here you can write tan theta is equal to r upon a minus x. All right, and you can compare these two, right? From the equation 3 and 4, from equation 3 and 4, we can take tan theta is equal to tan theta, which is equal to here these two equation, right? So it will be 8a upon 3r is equal to r upon a minus x, and we have to solve and simplify this whole thing. So you can transfer this a minus x to the left, isn't it? So it will be 8a times a minus x upon 3 is equal to 8a times a minus x is equal to, even r you have to transfer it to the right hand side, it will be r square. All right, so this is r square part we got, fine. And we know what we know. We know that in the beginning we calculated here r value, that is square root of 2ax minus x square. So here r is equal to square root of 2ax minus x square. So r square is equal to 8ax times 8a minus x upon 3. So r square substitute value here, so it will be equal to 2ax minus x square is equal to 8a times a minus x over 3. Transfer this 3 to the left, means 3 times 2 is 6ax minus 3x square is equal to 8a square minus 8ax, right? So transfer this right hand side part to the left and we will be having quadratic equation 3x square, and this 8a square is equal to 0, and this is quadratic equation we will get. And we have to use here quadratic formula. Using quadratic formula, here x is equal to minus 14a plus minus square root of minus 14a bracket square minus 4 times 3 times 8a bracket square upon 2a is just 2 times 3, that is 6. And we have to simplify this one completely, that is 14a plus minus square root of 196 minus 96 is 100a square upon 6. So if you take the square root of 100, it's just a 10. So it will be 14a plus minus 10a upon 6. and we will get the two values of x. One is x is equal to 14 plus 10 is 24a upon 6, that is just a 4a, or x is equal to 4a upon 6 means 2a by 3. Fine. So as in the given question, as x is less than a, from the diagram, if you look at this one here, this a is radius and the x is just a small part of this radius, isn't it? And that's why x is less than a, so we have to accept just a x is equal to 2a upon 3, this value. All right, so that's it. Fine, this is the answer. Understood? I hope you got this derivation completely. You can watch it again, fine, and solve this again so that you will get it. Okay, and if you want to connect with us, our regular batches and things like that, for further math one-to-one lessons, I have left the contact in the description box. That's it. Enjoy the maths.